Hey, hi everyone. Good morning. I welcome you to all for the webinar of time series in MongoDB. I'm Chandrika, working as Associate Database Engineer at Mydbops. I have keen interested on MongoDB performance along with troubleshooting, and also I used to write their blogs on MongoDB as well. MyDBOs will support both consulting services and managed services with 24/7 with DBA team support. We majorly focuses on MySQL, MongoDB, and PostgreSQL. This is the essence of today's webinar. We'll go with the introduction and the behavior of time series and how to manage the time series collections along with the best practices. In introduction, we'll know about what is the time series and how it differs from the normal collections. Let's define the time series. Time series is the sequence of data points in which insights being gained by analyzing changes over the time. In real time, we are using a lot of time series or IoT devices, right? Like smart refrigerators, smart bulbs, smart watches. And also, we used to check weather temperatures very frequently. And we may invest our money in the stock market as well. This all will produce a lot of data based on the time. We need a database to store all this data. In the market, we have a lot of time series databases like Redis, Prometheus, InfluxDB. And MongoDB also introduced a new feature in MongoDB version of 5.0, which help us to store this huge amount of data based on the time. Let's discuss deeply about time series in further slides. Maybe you have a question, what and why the time series and how it differ from the normal collection. Yeah. As we ever write, we can do the operations like insert, find, agree, count operations in normal collections. The same operations can also be performed in the time series collection as well. The main difference between the time series collection and normal collection is all about storing of the data. We store the data in an efficient manner, which helps us to improve the performance as well as decrease the storage management as well. Let's discuss deeper about the time series and the functionalities in the further slides. In behavior of the time series, we will discuss about how to create a time series collection and the benefits of time series along with other features as well. Benefits of time series. By using a time series, we have a lot of benefits. Coming to the space management, in time series collections, while you insert the data, it internally use some compression algorithms which used to compress the data on higher ratios, which internally decreases the storage size as well. In this manner, time series help us in the space management. Coming to the data management, while you insert data from into the time series collections from application and write, it internally groups the data based on the metadata and keeps all matching metadata data into a single document in system.bucket.time series collection. Let's discuss about this collection more deeply and briefly in further slides. Coming to performance scenario, while you create time series collection, it internally creates one more index on time field, which help us to improve the performance of the queries as well. Time series components. This plays a major role, and also we should aware of these time series components, which help us to create a time series collection as well. We have three different types of time series components: time field, metadata, measurement. Time field is represented as a time when the data point being recorded. Metadata is a label or unique that identifies the data uniquely. Metadata should be remain same over the lifespan of the time series collection. Measurement is a data being captured at different time intervals. Let's understand or we'll know about the command to create a time series collection. Here we are going to create a time series collection which is named as win sensor with the time series components as we discussed. PS represents the time field, metadata as meta field, and granularity as a seconds. Let's discuss granularity in further slides. Once you created this time series collection, it internally creates other two more collections which is named as system.bucket.winSensor and system.use. Here we are going to insert few amount of data into the winSensor collection. We have been inserting two documents which is having a metadata as meta field, TS as a time field, and value as a measurement. Inside the meta field, we can also have sub-documents as well. And also we need to observe one thing that we are been inserting a two documents which is having a same metadata. Let's discuss about the granularity in a time series. Granularity refers to the level or a precision at which the time series data is stored and queried from the time series collection. There are different levels of granularity. They are seconds, minutes, and hours. If you not set any granularity level for the time series collection, by default, it choose the granularity level of seconds. And also, we would recommend to set the granularity level as a seconds if you have very high frequency of data being inserting into your time series collection as well. And also, granularity helps us to determine the maximum lifespan of single bucket. Let's map this granularity and the bucket lifespan. If you set the granularity level as seconds, the bucket time span would be a 1 hour. If the granularity level is it's a minute, the bucket time span would be an entire day. And if it is hours, the bucket time span would be a month. Let's understand this granularity and with the bucket time span with an example. As we discussed, while you create a time series collection, here we created the sensor collection, as you know, right, guys. It internally creates other two more collections, which is named as system.bucket.winSensor and system.use. Here, you can view it like while you've been inserted data into the winSensor collection, it stores the data in a normal format as it's been stored in a normal collection. The main difference would be in the system.bucket.winSensor collection. Let's discuss about more deeply with about this collection. As I stated you before that in time series, it used to group the data on metadata. And also we've been inserted two documents which is having a same metadata, right, guys? So in this collection, it merged the two documents and kept into a single document. Inside this document, we can also get the info like min and max, the document details along with the metadata. Inside the data, as a sub documents, you can also have other information as well. In right side of your screen, you will also have observe another screenshot being attached. This is also having two documents inserted into the winSensor collection with the same metadata. And also you may have a question that why these two documents be not matched based on the statement I given you before, as it used to group the data based on the metadata. But here is the answer, guys. While the newly attached screenshot being inserted at 11 a.m. on June 20 and the previous data being inserted into the time series collection at 10 a.m. on June 20. And we also know for winSensor collection, we have set the granularity level as seconds, which means the bucket would expire after 1 hour. So the previous data which been created at June 20, 10 a.m. will be expired and creates a new bucket at 11 a.m. So in this manner, the data will be organized in the time series collection, which also help us to manage this huge amount of data which been inserting in different time intervals. We can also change the granularity level of time series. If you want to change the granularity level from seconds to minutes, here is a command to change the granularity level. We need to use a call mode command at runtime along with the collection name with time series granularity as a minutes. Here in this place, we need to note few points. Let me explain you about. If you want to change the granularity, we need to change the granularity level by 1. But we can't change the granularity by 2 levels at a time, which means, for example, if you want to change the granularity level from seconds to hours, then you need to change the granularity level from seconds to minutes and then minutes to hours. And also, once you've been increase the granularity level by 1, you can't even decrease the granularity level to the seconds back again. Before going to discuss about the materialized views, let us discuss about the other collection being created automatically, which is system.views. System.views will help us to organize data automatically while you've been inserting data into a time series collection. And also, any type of queries will be pointed to the time series collection, which is a win sensor in our example case, will be internally depends on system.views collection as well. Let's come back to the materialized view topic. We can also create a materialized view on top of existing time series collections as well. You can use this materialized view creation when you have a scenario of hiding few amounts of data for some analysis, analytics, or archiving or understanding internal patterns of the collection. You can use this materialized view. Because we suggest this materialized view because for all this analysis, right? When you modify, there is no relation between the base collection and newly created materialized view. As there is no relation between the materialized view and the base collection, the data you've been modifying on the materialized view will not depends or modifies on the base collection. And also for improving your query performance on materialized view, you can also create indexes on materialized view as well. Let's discuss how to create a materialized view from the time series collection as well. Here we need to use some aggregate command for matching your condition and use a $match statement to move your all matching data into your newly creating materialized view. Let me explain my command with you. Here I wanted to create a materialized view which is named as WinSensor_view from the base collection WinSensor, where the value is greater than 1. Need to be pushed into the WinSensor_view. Here is the command for the same. Let me explain you about the cluster indexes. Cluster indexes stores the index key and value together. And also collections which are having a cluster index is known as cluster collections. Cluster collections store the documents ordered by the cluster index key and value. You can choose the cluster index as an option when you are having more queries, which is based on the equality or range based queries. By using cluster indexes, we can also decrease the storage size of your collection as well. Here is a command to create a cluster index along with cluster collection creation. We need to use a runtime command using a option called create. We are creating a collection named as WinSensor with a cluster index key of ID. And also we need to set cluster index as a unique true. It is a must required condition. And also if your key is sequentially increasing in the values, right, it also help us to increase the performance of your query as well. And also we can have an option to customize your cluster index as well. Here we are setting the cluster index name as WinSensor's cluster key to identify very uniquely from all other existing collections indexes. We are also having a few limitations for cluster index along with the collections. Let me explain you about that. You cannot transform a non-cluster collection to the cluster collection. or clustered collection to the non-clustered collection in reverse. In meanwhile, you wanted to move the data from clustered collection to the non-clustered or non-clustered collection to the clustered collection, then we need to use these following commands. Take the dump using a mongodump command from the base collection and use a mongo restore command to restore the data into a destination collection. Or use the aggregation pipelines like $match, $out to move your data as well. And also, you cannot hide a cluster index. And also, capit collections won't support in cluster collections. Yeah, sharding. Time series also will be supported in sharding level as well. We need to use a method called sh.shard collection with the namespace of sample.winSensor, which is our namespace of the collection, along with sharded key, meta.sensor ID, along with time series components. As TS as a time field, metadata as meta field, and granularity being set as seconds. Here we have a few limitations in the sharding level that we cannot reshard the existing shard key, but we can refine your shard key for the time series collection as well. If you already have an existing time series collection and you wanted to make it as a sharded, then we also have a command to make the existing time series collection as a sharded as well. Just we need to use sh.shard collection with the namespace along with the shard key against the MongoDB, which help us to create a sharded time series collection as well. Let's discuss how to manage the time series collections. Indexes. We all are aware of the indexes and how it works. Indexes will improve the query performance as well, and also help us to decrease the CPU utilization and disk utilization as well, right? In time series collection, we have two types of indexes, which is named as cluster index and secondary index. When you create a time series collection, it internally creates an index on the time field, which is named as a cluster index. Along with the cluster index, as we discussed, it helps us to decrease the storage size too. Let us discuss the secondary indexes in the further slide. You can have a secondary index to provide additional flexibility of your data while you are querying, and also for improving your performance of the query. You can also create secondary indexes on all the fields you require. Before going to discuss, let's check about the limitations of secondary indexes with different Mongo versions. In the MongoDB version of 5.0 and earlier versions, you can create a secondary index on meta field and the time field, or any subdocuments of meta field as well. From starting MongoDB version of 6.0, MongoDB introduced other new features as well, while creating a secondary indexes on time series collections. You can create index on secondary index on time field, meta field, or any subdocuments of meta field. Apart from this, you can also create secondary indexes on any other existing fields or any other existing subdocuments of fields. Let's map the secondary indexes and cluster indexes. Let me tell you with an example. If you have an cluster index which is named as name:1 and secondary index with name along with user, and you have a query which satisfies these indexes, then your query optimizer by default will choose the secondary index as an index. But we suggest you use a cluster index to improve your storage efficiency as well. To achieve this, we need to use a hint from the application and using a cluster index. And also, TTL index and text index and do this PR index will not support in time series collections. As we discussed, TTL index won't support in time series collection, but there is an option which is named as expire after seconds, which help us to delete the documents automatically once it reaches the specific threshold. This threshold will be depends upon the time field value plus number of seconds you've been enabled for the expire of the seconds parameter. In the below, you can see an example for with expire of the seconds. Here we are going to create a collection name as weather with time series components, timestamp as time field, metadata as meta field, granularity as a hours. And also we set expire of the seconds as 86,400, which means a day. As of now, we seen about expire of the seconds parameter and how to create the collection along with expire of the seconds parameter. Let me tell you how it internally works. Once you've been enabled this expire of the seconds parameter, there is a deletion worker which runs internally in the background for every 60 seconds once. And the main role of this deletion worker is to find the documents which satisfies the expiration threshold and moves all the documents into a single bucket. And all the documents in the bucket will be removed in one run, and the buckets itself will be removed in the next run. And also you may have a question, it is deleting a documents. Maybe you can have an idea that it will impact the server performance. Here is the answer. It runs as a single threaded one. As it is single threaded one, it won't impact the much of the your server performance as well. And also you already have an existing time series collection and you wanted this automatic deletion of documents, then you need to use a call mode command at runtime using expire of the seconds parameter being setting with the threshold or the value you require. Once you've been set it, you can view the already set values using a list command at runtime. And once you set it, you wanted to increase or decrease the expiration threshold, then you need to use the following command to change the expire of the seconds value. Here we have been changing the value from 1 day to 2 days. To delete the documents, we have been enabled expire of the seconds parameter. If you want to stop this process, just we need to use a off value with expire of the seconds parameter, which help us to stop automatic deletion of documents. Let's discuss about how to migrate the data into a time series collection. For migrating data into a time series collection, we need to follow a few steps, like create a new time series collection. You can also skip this step if you're already having an existing time series collection. Take the dump of data from your source collection and dump and store it in your server level. And you can use a MongoDB command to restore the data into your existing time series collection or newly created time series collection. Maybe as of now, I discussed it have a different storage optimization and using a different compressions or higher level compressions. Maybe you have a doubt, right? It uses a snappy compression. Let me discuss you about these compression types in further slide. Yeah, time series collection will have a different compression, which is named as JDST, whereas normal collections will use a snappy compression. ZSTD will provide a higher compression ratios compared to the normal snappy compression, which internally help us to decrease the storage size. And from the MongoDB version of 5.2, time series also can use the columnar compression. Columnar compression is a technique used to compress the data on column-wise rather than row-wise. Let me explain more detail about the columnar compression. Columnar compression works by storing the data values from each column together instead of entire documents or rows. And this small columnar compression will internally depends upon White-Tiger storage engine. White-Tiger uses a compression called prefix compression to compress the data in a column-oriented manner. Let me explain you about the best practices to improve your time series collections performance as well. Optimization of inserts. we all been inserting a lot of data from your application and based on the different time intervals. Maybe we'll use a single insert statements. To optimize the inserts and decrease the server impact, we can use insert many by grouping the data from the different time intervals with the different multiple measurements into a single insert many statement, which internally help us to decrease the impact of inserts on the server level as well. In this manner, we can also improve our time series collection performance. Right. Optimization of compression. To optimize the data compression for time series collection, we need to follow a few steps or methods. Please omit the documents which are containing empty objects or empty arrays. Round the numeric data until to the precision from your application. By rounding the data to the precise values, which help us to increase the compression ratio as well. Let me explain about the compression with an example. Here is an example which is being inserting 3 documents into the Vincenzo collection. Let me explain you about that. We have a metadata which indicates meta field and TS as a time field value. Let keep an all eyes on the value field. In the first document, we are having a value within an array of 2 values. In second document, value field is having an empty array. In third document, value field is having a 2 values within the array. There is a schema change when you compare first and second documents. Because of this schema change, the second and third documents will remain uncompressed. So please avoid this type of scenarios to improve your compression as well. Let's discuss about the limitations of time series. Here we don't in time series we don't have any change strings or client side field level encryption, database triggers, or we can't even reindex or rename the collection, and also schema validation rules. We can't even change the time field and meta field enter the lifespan of time series collection, and captive collections won't support in time series collection. Hey guys, we are at the end of the webinar. Please let us know if you have any questions in below Q&A sessions. Thanks each and everyone for joining with us on this weekend. Have a great day and great weekend ahead.